You can continue to optimize. You probably could improve the experience more if you optimize more, but you're going to get like diminishing returns after that point. It's probably better for you to invest in other business critical things than to continue obsessing over performance. It depends. This is why we think measurement is so important.
This is the Technical Marketing Handbook, a podcast sponsored by Simmer, where we talk about the technologies, concepts, and phenomena relevant to those working in digital marketing. In today's episode, we will be talking about core web vitals, and we're joined by a very special guest. So enjoy the show. Hey everyone, I am your host, Simo Ahava. I'm the co-founder of Simmer, a company where we build online courses, teach folks about technical marketing, and among other things, sponsor this podcast. As this is the first episode of the podcast, I think I might have to explain myself a little. First, why another podcast? Wasn't 2020 peak podcasting? Look, I don't know. Maybe I had too much time on my hands, or maybe I thought there's still a niche out there for folks looking for education about tools and the technologies they engage with on a daily basis. But whatever the reason, here we are. The purpose of this podcast is to educate and to tackle the ultimate challenge of explaining these technical concepts without having access to the visual medium. Some of these episodes will be solo content from me, and in some, like this one, I will be joined by a guest who most certainly knows about the selected topic far more than I do. In today's episode, we're going to be talking about core web vitals, a newish set of metrics for measuring site speed, page performance, and user experience as a whole. It's something of a shift from how performance measurements used to be done, as before performance was something that was fairly clinical as a metric, bound to specific milestones that were collected automatically by the browser. So there were things like server response latency, page load time, content render speed, and so forth. The point being, these original metrics are kind of lab created. And what I mean with that is that they do indeed measure page speed and page performance, but they do so with metrics that might not actually reflect on the user's experience of how fast the page is to load. So what these Web Vitals metrics seek to address is this disconnect between actual performance and perceived performance. There are numerous studies out there that reflect on the importance of performance optimization, and if you believe some of them, then every millisecond you shave off from the page load time will result in millions of dollars of additional revenue in your web store. Well, don't believe that study. That's just gross exaggeration. But the reality is that speed is important. Just think about your own browsing habits. When you search for something in a search engine and you click the result, how likely are you to wait around for the page to load if it's super slow to load when you know there might be a faster site in the search results? Or what about when you're ready to buy something? If it takes a long time to go through the checkout funnel or just to make the purchase, you're introducing friction between the decision and the action. And that's the last place where you want to introduce any type of friction or complexity. You want the user to just zoom through the checkout funnel without having to worry about, did the page load, did my button click work, and so on. It's important to constantly strive to improve the performance of your pages and the assets loaded on those pages, because it has become such a fundamental piece of the user experience puzzle. And it's also easy to fall into the trap of thinking that, computers and network connections are becoming faster and faster all the time. They'll take care of optimization for me. But that's just not how it goes. Page performance isn't something given to you for free just by virtue of you being so lucky that your users are coming from well-off countries with fast internet connections, because that's just not how the world works. No, it's something you need to foster and nurture, because there's a whole ecosystem of broken technology stacks and outdated network machines that really just do their best to bottleneck your page load at every possible turn. Now, I'm so incredibly honored to be joined on this podcast by Google's own Philip Walton. First of all, he's a super smart and super nice guy. I've been following him for a long time. He's one of the authors of the AutoTrack Google Analytics library, which really is a precursor to what enhanced measurement in GA4 is now. I'd like to say that we have a similar background. He built his first website in the late 90s, as did I. I do think that our websites might have been considerably different, though. And he's worked at Google since 2014, and for the last 5 years or so, he's been a senior developer programs engineer working with Chrome and the web platform. Working on client-side libraries, working on documentation, just doing a whole lot of work to improve how these tools are explained to the general public, for example. One of his most visible contributions when it comes to Web Vitals is that, first of all, he's one of the brains behind the JavaScript libraries themselves that do the client-side measurement. But he's also one of the authors of the web dev documentation for Web Vitals, so the developer documentation used by developers who want to measure and improve on these metrics. So if there's anyone who can spill the beans on the engineering marvel that Web Vitals are, it's Phil. We're going to jump into the interview after a few short words from our sponsors, so stick around.
Are you a marketing or a data professional looking to skill up? Take a look at the online courses Simmer has to offer at teamsimmer.com. The courses are completely self-paced, and your enrollment will grant you lifetime access to the material, including any updates. Go to teamsimmer.com and use the coupon code HANDBOOK to get 10% off your course purchase. That's teamsimmer.com.
Philip Walton from Google, could you please explain what the 3 current core Web Vitals are and what they measure?
Yeah, sure. So the 3, well, let me actually start by talking a bit about the Web Vitals program, and then I'll mention what core Web Vitals are, because I think there's a bit of confusion between those 2 terms. So Web Vitals is like the name that we gave the entire initiative. It's kind of the more generic name. We sometimes use the term to describe individual metrics, but more often than not, it's the name for the initiative. And then Core Web Vitals is a subset of metrics within that initiative that we think are kind of the most important metrics, kind of performance and user experience metrics that website owners should measure as a way of determining whether they're providing a good experience to the users or kind of a poor experience. And those 3 metrics are kind of broken down into 3 kind of pillars of the user experience. So we have, loading performance, we have interactivity and responsiveness, and then we have kind of visual or layout stability. So the first metric from loading is called largest contentful paint, or abbreviated LCP commonly. And that measures the point from when the user first begins to load a page until the largest either block of text or image appears and is fully rendered and painted onto the screen. So if you have a website with a very large headline that uses a web font, then once that font has finished downloading and then the browser can display the headline using that special font, that would be the point at which largest contentful paint happens, and it would be measured from when the user kind of clicked on the link to load that page until that headline was presented. If you have kind of a large hero image or marketing banner, the point at which that image is displayed would also be largest contentful paint.
Right.
Something that I've heard people there's a bit of confusion about. Sometimes people think, it's like a group of elements, or if I have a modal, is it the whole modal? So it's actually not. It's always individual elements, so individual text blocks or images. So the second core vital metric is FID, or sometimes pronounced FID, for first input delay. This one is, there's some confusion about this one, so I'll try to go into a bit of maybe unnecessary technical detail here. But
that's perfect.
The idea behind FID is that it measures it measures interactivity on the page, but it actually kind of measures the opposite. It measures when the browser is unable to let the user interact. So imagine you go to a web page and you see something on the screen, You see a link, you see a text field, you see a button, and you go to tap on that, and then nothing happens. So fit is kind of measuring that experience, where because the browser is busy doing other things, it is unable to respond to the user's intention to interact with the browser. And so the word delay there is quite key. It doesn't measure the entire input experience, like from interacting to seeing something happen. It actually measures just the delay portion, and there are a couple of reasons for that are probably too detailed to go into. But it essentially measures what's known as made thread blocking time. So if the browser is parsing JavaScript, if it's doing a bunch of other work, if it's trying to render the page, if it's doing something that prevents it from responding to the user's input, then first input delay measures that kind of gap. And we generally say that, I actually didn't mention this with LCP. For LCP, we generally say that you want to have that largest paint happen within 2.5 seconds of loading the page. So for first input delay, we want it to happen within 100 milliseconds of the user attempting to interact with when the browser is actually able to run the code needed to do the interaction.
So that's the kind of pain threshold.
Yeah, right. And so one of the things that we've also tried to do with Core Web Vitals is we tried to base all of our thresholds and our recommendations on kind of two things, on both like user research and kind of human computer interaction, like the best practices we have about that, but also based on real achievability in the wild. So we'll look at the research. We'll try to see what user studies show users find to be good experiences, but then we'll also look at thousands or millions of web pages and see how they're actually performing on these metrics. And we'll kind of pick a number that we feel like is both achievable, but also provides a good experience. So in the case of LCP, we didn't want to go kind of, the user research would say somewhere between 1 and 3 seconds. And we ended up picking a number on the higher end there to make it more achievable. With FID, it's actually 100 milliseconds turns out to be quite achievable. It's probably the easiest of the 3 metrics for sites to kind of hit the good threshold. But we didn't want to go much lower than that because it would be outside of what the user research suggests. It suggests that people generally find anything within 100 milliseconds to be seen as instant. So anyway, we have some ideas about how we could improve that metric to make it a little bit more representative. But that's too much of a tangent. Let me get on to the third Core Web Vital, which is cumulative layout shift. This one is it's interesting. It's probably the newest. It's the first metric of this kind that I'm aware of in the web performance space because it doesn't really measure a time. Almost all the other metrics measure a time. Cumulative layout shift measures the visual stability of a web page. If you've ever gone to a page and you were reading some text and then suddenly an ad popped up and then the text shifted to outside of the viewport or somewhere else, and you lost your place reading, then you've experienced this problem that we're trying to prevent. Or if you've ever, maybe been typing some characters into a search field, and the page was presenting a search suggest list, and you saw your suggestion, you went to tap on it, and right before you tapped on it, an additional search item appeared in that list, and you clicked on the wrong one. So I think we've all had these experiences. So these experiences are what this metric is trying to help us kind of avoid. It's this idea of if there's something that is on the page, it should not shift to a different point on the page unless the user has done something to kind of make it shift. So like if you click a drop down and then the drop down appears, obviously that was intentional. That's what the user wanted to see. So that would not be considered like an unexpected shift. But CLS is trying to quantify these unexpected, undesirable layout shifts that happen on the page that could distract the user or, in the worst case, kind of cause them to do something they did not want to do. It's the score is also a bit kind of hard to understand. So it's an individual layout shift will have a score, and for an individual layout shift, the score is essentially a measure of how much of the visual viewport moved or shifted and how far did it shift. So it's kind of you multiply like the the area that shifted times the distance that it shifted, and that will give you a score. And then the cumulative nature of it, and actually we changed the definition of this recently, but the cumulative nature of it currently is that it measures kind of the worst burst of layout shifts that happen in a given short period of time. So like right now, the definition is if 1 second elapses, if there's a bunch of shifts that happen all together, and then kind of 1 second elapses, that defines the edge of that window. And the window can be a maximum of 5 seconds long. But so every layout shift that happens within that window just gets totaled up, and that's the cumulative nature of it. And then so we say that to provide a good experience, the individual layout shift scores accumulated within that window should not be greater than 0.1, which roughly, doing some fuzzy math here, roughly translates to, 10% of the visual viewport shifting in kind of that short period of time. So if less than 10% is shifting, then that's considered to be a good experience. If kind of more than 10% is shifting, that's considered to be a poor experience, or an experience that kind of could use some improvement.
Right.
It's not exactly that, but it's roughly the 10% amount.
First of all, thanks for that walkthrough. You talk about scores and thresholds, but Web Vitals are something that anybody can measure. Like you can add a library onto your website or whatever, and you can measure them by yourself and use that data for something. But when you talk about scores and thresholds, you're referring to some report where you can kind of analyze this information, and there's a green and yellow and red or something there. Can you elaborate what you mean when you talk about like what the optimal values are, for example?
Yeah, and I guess I did kind of skip over that part. So this reminded me what you said. Another bit that's important about Core Web Vitals is we wanted to make sure that every one of the metrics we used is something that could be measured, what we call in the field, or which is often referred to as real user monitoring, or RUM data. And so we wanted to make sure that these metrics were representative of a user's actual experience, not something that could be simulated in like a page load experience in like a lab environment, but something that could actually be measured on users as they were using their devices, as they were interacting and loading pages. And so we decided that like we wanted to make sure these were all field measurable, which puts some constraints on what the metrics can do, because it has to be something the browser can kind of compute in real time without affecting performance. But yes, so that does mean that you can measure these on your web pages for all of your users, and it's something that we actually recommend everyone does. There's a JavaScript library called the Web Vitals JavaScript library that I work on that allows you to do this. There are a number of analytics providers that offer this as well. Off the top of my head, Cloudflare Insights, SpeedCurve, Akamai's Impulse library, New Relic, Datadog, Blue Triangle. I'm sure I'm missing some, but there are a number of web analytics partners that we work with that have added these metrics to their offering. I'm sure there are more. Most analytics services, you can use custom metrics to measure these. So that's where the Web Vitals JavaScript library could play in. Simo, you created a Google Tag Manager template that incorporates the Web Vitals library and helps you do it with GTM. And so we actually recommend that people measure this themselves on their own websites so they can get a sense for what their users are experiencing. That being said, we also measure this in Chrome ourselves. And that data is exposed in something called the Chrome User Experience Report. And this is something like the top, 8. It's always increasing, but I think right now about the top 8 million websites are included in this report. And so you can go to, if you just type in the Chrome User Experience Report in Google, you can go and see there are multiple dashboards of this, but you can type in your website and see what its Core Vital scores are. You could also go to PageSpeed Insights, which will show you field data, which is Chrome User Experience Report data. If you use Google Search Console and you're kind of the owner of that, you can log in and have access to that. Then you can see a report, the Core Web Vitals report, which also shows Chrome user experience data. And so the important thing to know here is that this is data that is measured by Chrome for real users. And so these are real users who have not opted out of sending usage statistics to Google. So this is going to be a subset of all users. but it is real users. And the numbers that I mentioned, that like the 2.5 seconds for LCP, 100 milliseconds for FID, and 0.1 for CLS, we recommend that you take the 75th percentile of all page visits, segmented across kind of mobile and desktop, and then the 75th percentile should be, 75% of visits should be ideally less than that threshold. So for LCP, 75% of your users should see that the LCP happen within 2.5 seconds. And so for FID, 75% of your users should have the first input delay be less than or equal to 100 milliseconds.
And would this Chrome user experiences report data or is it already being used, for example, by search engine for crafting ranking signals or something similar?
So Google Search announced about a year ago that they intended to incorporate the Core Web Vitals data from the Chrome user experience report into their search signal. I believe the last announcement said they were going to launch kind of in the middle of June and roll it out gradually throughout the summer, I think ending in August. I work on Chrome, so I don't have insight into exactly how much effect that will have on folks' ranking, but it will initially be applied to mobile search results. So if you are on your phone and you use Google Search, it could be the case that the ordering that you see is affected by the performance of the sites that are showing up in those lists. So one of the things, and again, I don't have details on how the ranking works, but one of the things that Google Search has publicly said is that this will be one of many signals that they use to determine ranking. And you can it's probably best viewed as a tiebreaker. So in a case where two sites have similar content, similar relevance to that user, then in those cases, the one with better performance could rank higher than the other one. And this is what they refer to as the page experience. So page experience is a ranking that they're using that incorporates Core Web Vitals. It also incorporates some other things like mobile friendliness and whether the page uses HTTPS versus HTTP, some compliance with the better ad standard, some things like that. But it does include the Core Web Vitals metrics. And so if two pages have kind of similar relevance to the user, then the one with a higher page experience score could be ranked higher than the other one. And again, this is what Search has kind of publicly said. I don't have any secret insight into this, but this is my understanding of how it works.
What about Web Vitals, especially CLS, which seems to be kind of a volatile measurement because it applies to things that are injected on the page, for example. Do you think this could result in a different obviously results in a different experience if I have an ad blocker that prevents ad injections, for example? I wouldn't have that same layout shift that others would have if they saw those ads being injected on the page. Would the Chrome user experience report take this into account, people browsing with or without, or having a different page experience in general?
Yeah, that's an excellent question. And the answer is yes, it would take it into account. This is something that we know is kind of a common point of confusion in the performance space, or people that are trying to understand these metrics. So one thing that we'll often hear is people will use a tool like Google's Lighthouse, and they'll run their page through Lighthouse, and Lighthouse will say they have no CLS, like CLS score of 0. But then they will go and look at the Chrome user experience report, and they will see that they have a CLS of 0.4 or something. And then they'll think, why is there a difference between these two Google tools that are telling me these two different numbers? And the answer is most of the time, so Lighthouse is a lab-based tool. It runs a simulation. It runs the page. It loads it up. There's no user involved, and it stops recording once the page is finished loading, and then it gives you a score, kind of gives you a report of all the areas for improvement. It's a fantastic tool. It's great when you're developing to make sure that the code that you're releasing is not going to be have all these performance issues. But it does have limitations in that there's no user involved, and it doesn't measure like a user, would load a page, scroll to the bottom, click on something to show a modal. None of that interaction would be captured in Lighthouse, at least not yet.
Right.
So another thing that's not captured in Lighthouse is something like personalization, or if somebody's using an ad blocker, as you mentioned. So if I'm logged into a site and that site is going to show me different ads or different banners or different whatever based on my personalized settings on that website, Lighthouse is not going to know that. Lighthouse is probably just going to show like a generic view with no user, or maybe it will show your development user if you've logged into that page. But what's being measured by the Chrome User Experience Report is all of the users who are actually coming to your pages and interacting. And if they have extensions that are randomly causing layout shifts, then those will be counted. Most people do not have those. This is one of the reasons why we use the 75th percentile. So there could be some people that have, if we used average, then somebody with that extension could affect your overall score. But we generally don't see that happens. So unless it's the kind of thing that many, many people are using, then it shouldn't affect your scores to the 75th percentile. But it is the case that, if 50% of your users are logged in, and logged in users experience more layout shifts than non-logged in users because you show something to the user and then you make a request to the server to get their personalized information. And then when that request completes, you add some new content to the page and that pushes everything else down. That shift that is only seen by those logged in users would probably show up in your CLS metric at the 75th percentile. Whereas for the non-logged in users, it would not show up.
Right. When we think about Web Vitals, do they replace, in your world or your view, do they replace the kind of traditional page timings, the clinical timings of server response time and DOM render, which are, fairly similar across the board when you start gathering enough data? Do you think there's an evolution, or are they on a complementary track measuring something completely different?
So I don't think they replace them, not all of them anyway. But I would say, and what we generally say is that if you are new to performance, or if you don't want to get super deep into performance, you want to be kind of know as little as you need to know to get by, then we recommend Core Web Vitals is what you look at. It's kind of the minimal set that will have like the highest return on investment. It's the main things that you need to know or should need to know to provide a good experience. That being said, let's say that you have a high LCP on your page and you don't necessarily know why. These other metrics can be very useful in diagnosing the problem that's causing the high LCP. So, for example, if it's taking a long time for your images to load, that could be because you have a slow server, but it could also be you have a very fast server, but you have, a bunch of blocking styles and JavaScript that you've injected into the head of your page that is then fetching some, again, blocking. And when I say blocking, I mean something that prevents the browser from displaying any content until it's completed. So if you're using something like an A/B testing framework, maybe you are making a request to Optimizely with the user's credentials that will return some response, and then the Optimizely script has to figure out which experiment that user is in. And then once it figures that information out, then it can like present something onto the screen. So in that case, it could be that your server is super fast, but because you're doing this A/B test in this specific way, now it's taking a while for your images to show up on the screen. And so these other metrics, like the navigation timing API metrics, so like your server response time, kind of when the request happened, when the response was received, when the DOM was computed, when the load event happened. Like sometimes these events, if you know like your architecture, you can use these events and their timings to understand where the problems are, where the opportunities are. But we probably would never, and I say we meaning like Google, we probably never design a metric based on when the DOM content loaded happened, because it's not necessarily relevant to what the user sees. Like it could be the case that the browser can paint some relevant content to the user prior to the DOM content loaded event firing. But it could also be the case that the DOM content loaded event fires and you have some CSS that makes the entire screen invisible until some other thing happens, and then you show everything to the user. So depending upon the site, DOM content loaded may or may not have any relevance whatsoever to what the user experiences. So in that sense, they're not super relevant to today. At least they're not relevant in terms of like making generic, largely applicable metrics that we can kind of say that these should be measured by all websites, all across the internet, because they just don't apply necessarily.
Right. I think one of my biggest pet peeves with the navigation timings, especially when they interject with Google Analytics reports or in Pingdom or in Lighthouse, was that it seemed to become a race to get 100 and this, get green marks across the board, whether it's for JS performance or CSS or the types of images load, and specifically cache headers, which seem to be a very tricky thing to get right. And I always, as a consultant working with people who are just and clients who are trying to get these to work, it always seemed to run into roadblocks when working with third-party libraries such as Google Tag Manager, which by definition needs a very short cache lifetime because it needs to get a fresh version from the servers every now and then. Do you think Web Vitals as metrics are going to be similarly like a blind pursuit of performance perfection, or is it possible to attain good marks without having to sacrifice hours and hours of optimization work? Are they more sensible in that way, or can they be modeled more easily without making huge compromises for other aspects of the site experience?
Yeah, I can relate to this desire to get 100 on Lighthouse or to get the best possible score. One of the things that we did with the Web Vitals program is we chose kind of broad buckets or thresholds, and we wanted them to be achievable. I mean, I think Lighthouse, it's something like 90, 98 or 99%, of sites won't have 100 on Lighthouse. It might even be more than that. It's very difficult to get a 100 on Lighthouse for any site that has any kind of complexity. Like you can create a static blog and get 100 pretty easily, but if you have a site that has any kind of complexity, or if you're using something like you mentioned, Google Tag Manager, that has this script that has a specific cache requirements that you can't really change. If you decide, well, I want to use that, then yeah, maybe you can't get 100 on Lighthouse anymore, because you're always going to have that, that maybe like that one blocking task that pushes out your TTI or some other thing that you just have no control over. So the idea behind, the Core Web Vitals is that, it is possible to have a site that loads fast, but still has the worst caching headers,
right,
like setup possible. You can have, everything can be not cached ever. But if you have a fast server, and if you have a bunch of people who happen to live near where that server is, maybe all of those users have super fast experiences. And so like the philosophy behind Core Web Vitals is we don't necessarily care how you get the good performance, as long as like what the user experience is good. And so in the case of using something like Google Tag Manager, it is certainly possible to use Google Tag Manager in a way that the user doesn't notice a slowdown. And so, we want the metrics to not penalize you just because you use Google Tag Manager. It is also entirely possible, and we actually see this much more frequently, where a marketing team will have access to Google Tag Manager. Maybe they're not as sensitive to performance, or they're not thinking about it as much, and they'll add a bunch of tags that totally slow down the page. And so in this case, it wasn't necessarily Google Tag Manager's fault. It was how it was used. And so the goal is that these metrics would kind of, by measuring what the user experiences, it's not necessarily assessing the technology, it's assessing the experience. And we think that's better. Also, to another point of your question, we chose these kind of wider grain thresholds intentionally. We didn't want to have I think the Lighthouse score is good, and I think it like really incentivizes people to do better. One of the things that we've said with Web Vitals is, if you are getting within the good threshold for 75% of your users across all of the metrics, if you decide then you're done optimizing for performance, that's okay. You can continue to optimize. You probably could improve the experience more if you optimize more, but you're going to get like diminishing returns after that point. It's probably better for you to invest in other business critical things than to continue obsessing over performance. It depends. This is why we think measurement is so important. Like one of the reasons why we recommend people measure these metrics, especially doing it in their own analytics system, is because then they could maybe correlate it with some of their other revenue metrics or other engagement metrics that they have. And they can see, if I optimize LCP 10% more, even within that good threshold, am I getting any noticeable business impact from that optimization? If I'm not, then maybe it wasn't worth it. But from the Google's perspective, we kind of have said that if you get this threshold, you don't necessarily need to optimize further. And specifically on the search side, Google Search has said that once you hit the good threshold for all of those metrics, you do not get any additional ranking boost by optimizing further. So if if there are two sites and one of them gets LCP in 2.49 seconds, and the other one gets sub 1 second LCP, so it's this blazingly fast experience, that second site is not going to be ranked above the first site purely based on like the page experience score. It might be ranked above them from other reasons. There's a whole host of reasons it could be ranked above them. But Google has said that they will not factor in ranking like once you've hit the good thresholds for all three. So I think the hope is that it has a good kind of balance to it where people want to focus on performance, but it's not the only thing that matters. Like there are many, many things that matter. We think that historically people have not focused on performance as much as they should. And that's one of the reasons why, Google Chrome has invested so much into exploring these metrics. And one of the reasons why Google Search decided to adopt the Chrome Web Vitals program, because they felt like they wanted to include some kind of user experience signal in their ranking. But it's not the only thing. It's not the only thing that matters.
So in terms of optimizing, if you are one of those who do want to keep optimizing and who wants to improve the performance, which I do agree with you, I think it's a very good approach to site management in general these days. What would be the kind of low-hanging fruit or steps that anybody should take to optimize against these Web Vitals metrics in particular? Things that any site can take a look at right now and figure out how they could improve on things like
Sure.
layout shift and input delay?
So when looking at the data, we've seen that the metric that most sites are not meeting the good threshold for is largest contentful paint. And most of the time that's happening because the website is using an unoptimized image, they're loading a very, very large, probably unnecessarily large, much larger than the viewport that the user is loading. If I'm loading your page on a mobile phone with 480 pixel wide screen, and your site loads a 3000 pixel wide image, that's kind of unnecessary. And if it takes me 5 seconds to download that image, then I'm not going to hit the recommended threshold for LCP. So we see that happening a lot. So I would say low hanging fruit is figure out some way to optimize your images. If you're using an image CDN, those usually cost money, but they're fantastic in terms of you don't have to think about. They'll optimize them for you. So you just upload your high resolution images to a website, and you get some code snippet, and then you put that on your page, and then they will figure out what device the user is on, what's their connection, what's their screen resolution in some cases, and then they'll serve the image that is appropriate for that user. This is typically like one of the best ways to improve LCP. Another thing that people commonly do, and I mentioned this before, things like A/B testing or personalization. It's often the case that a site will, get the initial server response back, and then they'll have to do some calculation to figure out what image to show, and then they'll make a subsequent request for that image, and then only after that request is received can the image be shown to the user. And so then there's kind of like two requests that have to be made. One request has to complete fully before the second one can even start. And typically this is a recipe for not hitting that threshold. So we recommend that people, whenever possible, get that request as early as you can. If you suspect that this something like an image on your page is going to be the largest contentful paint, find a way to deliver in that first request, maybe inlining it or something, or at least including it in the HTML markup, or using like a link preload tag that can tell the browser to start loading this as soon as possible. So I would say those are the two things for LCP. For CLS, you see this a lot with widgets and third party scripts. Actually, the number one cause of CLS, I would say, this goes back to images again.
Yeah.
The number one cause is, I think, people using images and not putting a width and height on their image markup in their HTML source code. So the reason that is problematic is because what happens is the browser then has to make the request to get the image, and it has to start getting the response. And then only once it starts getting the response does it have any information about how big that image is. And it needs that information in order to reserve the space on the page. So if you have an image and then you have text below that image, the browser doesn't know how big that image, if the browser doesn't know how big the image is, then it will render it as kind of zero height. And then once it gets the data, it will push everything else down and render the image. However, if you know how big the image is, and you say, this image is 600 pixels wide by 400 pixels tall, then the browser will reserve that space, or it will do the calculation to figure out the aspect ratio of the image, and it will reserve that space. And this is like, everybody should do this. Every single person, every single image you have on the web should have width and height on it so that the browser knows how much space is available. This is probably the number one cause of CLS. Another cause is, third-party widgets or social things or tags or ads or other things that, again, don't have space reserved for them. And so they load in and then they'll adjust the space somehow and they'll push some things around. In many cases, it's not necessarily a problem of using the tag itself. It's the problem of using the tag without the space being reserved. So in some cases, this is the developer's fault. In some cases, this is the widget's fault. We're working actually with a lot of the top kind of social tags to make sure that like their default snippet that they use, or the one that like Google Tag Manager will add if you add the default tag, will kind of do the right thing as best as possible. But as a developer, sometimes you can just say, well, I kind of know the most common size of this thing, and so I'm going to just reserve that space available on the page while it's loading.
So it's better to reserve some size, even if it might not be the actual finals. At least something is reserved, and the CLS will be smaller as a result.
For the metric, it definitely is, because if you remember from how I was explaining it, each individual layout shift is a measure of what like portion of the viewport moved, but also how far it moved. So if you reserve half the space needed, but it still shifts a little bit, it will have shifted by half as much. And so then the score will be half what it otherwise would have been. And so reserving some space is definitely better than reserving no space, at least from the metrics perspective. I think from the user experience perspective as well. Yeah, I was going to say something that I can't remember now.
Sorry, derailed you. I did have now that I've completely thrown you off, I can take advantage of you a bit more. And I did have a question about CLS with regard to lazy loading. So when you have a lazy loading page which loads content only after you scroll past a certain threshold, or even maybe even a single page app that loads content without actually refreshing the page, how does that reflect on CLS?
So I think that there are two questions there. So I'll start with the lazy loading question first. When the browser is doing its thing properly, and when the developer has done their thing properly, then a lazy loaded image the browser should detect that the image is about to be shown in the viewport. I mean, so typically you'll add like the loading equals lazy attribute on the image, and then the intention there is that the image is off screen initially, and then the user will scroll it on into view, and the browser should, in theory, detect that it's about to come into view, and then at that point display the image. If that all works well, there will not be any layout shifts. There could be cases, though, where it's an unusually large image and it takes a while to show it, and there could be a layout shift. But again, this gets back to if you've used the width and height attribute properly, then the lazy loading image, the worst case scenario is that the user just doesn't see the image right away, but there's no shift. And so like, it's definitely the case that you can use lazy loaded images and not have it affect your CLS if you use width and height everywhere. We know that, across the web, not everyone does that. And there are cases where these kind of popular like jQuery plugins or other things that load images lazily will end up causing CLS. And so hopefully over time, these things will be updated to kind of prevent these negative experiences. The second question you ask is SPAs, or single page applications. This is a kind of a very tricky part of Web Vitals. We don't have, unfortunately, like a super good answer to this larger problem right now. Specifically with regards to CLS, if you have a web page that then, like when you click on a link, so the way that an SPA works is instead of doing a traditional full page navigation, the code in the page will detect that a link was about to be clicked. And instead of loading the page, it will intercept that link. It will make a request to the server for the data for the new page. Once it gets that data back, it will dynamically update the page with the new data. And then the user doesn't necessarily know whether it was a full page request or a partial request. But when done right, it's quite a bit faster experience. Also, it means like if you were doing animation or playing video or audio or anything like that on the page, it didn't get interrupted to go to the new page. So in general, SPAs provide a pretty good experience to the user. The making the request itself and then updating the page, that could cause layout shifts. So I mentioned earlier that you only want to talk about like penalize unexpected layout shifts. So the way that we define that within the API is if a shift happened within 500 milliseconds of a user interaction, then we just ignore it. We say like, we're just going to assume, like it might not be the case, but we're just going to assume, give you the benefit of the doubt that the user did something to cause this layout shift. So in the case of a single page application, maybe I click on a link and maybe you load some content and then you update the page, and it all happens very quickly and it happens within that 500 millisecond window. And in that case, even if you do have layout shifts, they're ignored for the purposes of the metric CLS. But if the server happens to be a little bit slow that day, or something else happens that causes a delay, and maybe it happens in 600 milliseconds, now all of those shifts potentially could contribute to CLS. So this is one of those areas where, as a developer, you kind of have to. It's a real experience. Like if you have a slow server response, the user might be thinking, "Wait, did that click work? Like I'm not really sure. Should I click again? What's happening?" And so I think the metric is working as intended in that it's highlighting that the experience, the shift happened in a situation where it might not have been clear to the user that it was related to that click, depending upon how long it takes. So what we recommend doing is that, in cases like single page applications, unless you know that the data is already populated and it's going to be super fast within 500 milliseconds, you probably want to then show some kind of, loading skeleton or something that indicates to the user that something is happening, and do all your shifts at that point. And then once you get the data back, then just put them in their place in a way that won't have any shifting. We've actually done like a lot of, I think this is one of those areas where people fear that if they have an SPA, they're going to get a bad score in Core Web Vitals. When we've looked at the data, actually, the primary causes of high CLS on pages are not SPA route transitions. It does happen, but it's not super common. And so I think this is one of those cases where people suspect it could be harming them, but in most cases it's not. Of course, you have to measure for your individual site. If you are noticing that it's affecting you, the recommendation is to kind of do that skeleton approach where you show something to the user immediately to let them know that new content is loading. And then once it loads, you want to make sure that it can load in a way where maybe you have to clear the old page out and like put in a new page, or it's very site specific, but that's what we recommend. Another bit, and this might be kind of too in detail for your question, but another interesting bit about CLS and SPAs that unfortunately we don't have a good answer for yet, but we're working on one. Stay tuned. Follow web.dev for updates. You might find something about this in the next month or so. But if you are a single page application and the user lands on your homepage and then clicks on a product page and then clicks on the add to cart and then go to the checkout page, But all of those subsequent pages were loaded as route transitions. The browser still thinks that the navigation of this page was like your home page.
Right.
So if this like example app.com / whatever, just like / probably for the home page, then the browser thinks that was the page that was loaded. If it's the case that your checkout page has lots and lots of layout shift, then the user could navigate to that checkout page. Lots of shifts happen on that page. And then they look in the Chrome User Experience Report and they see that their homepage has lots of layout shifts. And they might be thinking, well, why? I don't think it's even possible that my homepage has layout shifts. And the reason could be because they happen on this other, quote unquote page. And this is an area where I think it's a little bit tricky. We recommend people, in their analytics, monitor when these route changes are happening, so that if you're seeing shifts happen in your analytics, you can at least debug them better and identify when they're happening, so you can fix them. Unfortunately, right now with the Core Vitals metrics, they will always get attributed to the initial page that was loaded by the browser. And again, this is something that we're looking at ways that we can better attribute this in the Chrome User Experience Report. It's a bit trickier to do generically across the web than it is for an individual site, like as the site when you're making these route changes, but a browser doesn't necessarily know. And since any app can change the URL at any time, as many times as they want, we can't just say that every time a URL changes, consider that a new page, because it doesn't match up with reality. Anyway, there's a lot of complexity there. It's an open space that we're looking into how to make better. But since you brought up SPAs, I thought I would at least kind of touch on that subject a little bit.
Now, that was super interesting. Do you think there's ever going to be a situation where sites can control what is being collected by Chrome? So a site could tell the browser that, hey, by the way, this is a SPA. We're going to the checkout. There's going to be a lot of CLS. Please stop measuring for now. Is that giving too much agency to the sites when this should be about the user experience, or what do you think?
I think for the purposes of Core Web Vitals, we would never do something like that. But I do think that we could design some metrics that we would expose in the Chrome User Experience Report that could involve site annotations in some form. So, for example, LCP is based on the element timing API, and an LCP has this heuristic where it says we're going to assume that the largest element is probably the most important element or the main content. But we know that that's not necessarily the case. Like, you could have any site could easily add a huge image to the page, and it might be irrelevant to the content.
And many do.
Yeah. So we have this. So also in the element timing API is this attribute where sites can then say, like, give me timing information on this image, or give me timing information on this text block. And so then that will show up in your analytics if you want it to. We could also potentially do something where we say, if you know that this is the most important element on your page, then attribute it with this DOM, attribute, and then we'll expose that information in the Chrome User Experience Report so that you can look at it, yourself. But we would probably never base a top level metric on something that we ask users to do. Just because it would be too easy for users to be like, I'm going to put it on this 1 by 1 pixel, GIF, and say that I have a super fast LCP. So unfortunately, we have to kind of think about those things. But I've definitely been involved in discussions where we talked about like giving site owners the ability to attribute in some form a metric that would show up in the Chrome User Experience Report. Today, that doesn't exist, but it's something that I know has been discussed.
So this segues quite neatly. We're about to wrap up shortly, but I have a couple of thought experiments for you. And the first one is that for some years now, especially spearheaded by Safari, the idea of tracking protections being something that the browser implements on behalf of the user to provide the user a better experience in terms of how they are being tracked across the web. And this has become prevalent across different browser vendors, and Chrome is as well working on this with same site cookies and new referrer policies and so on. Do you think performance, or is it already, but do you think it's also going to be more and more something that the browser will actively work on behalf of the user? Because it seems like, and following up from what you just talked about, by not giving sites the agency to manipulate web vitals, do you think browsers will take more role in suppressing elements that might be detrimental to the page experience, or forcing certain types of images only to load, or adding those width and heights some way automatically to images that don't have them? Do you think browsers are incentivized to take more role in this?
So I can tell you that it's definitely been discussed. I think we've even announced it at, I think even like maybe 2019 Chrome Dev Summit. We talked about we showed some mocks of Chrome saying, this page it looks like this page is taking a long time to load. Do you want to, go back, or something like that? We ended up not pursuing that particular idea based on just, concern from partners and site owners, and wanting just to make sure we do it the right way. Like, we don't necessarily want to make the decision on behalf of the user, but at the same time, users don't always know why the site is taking a long time. Like, is it because Chrome is being slow? Is it because the site is slow? Is it because the connection is slow? And Chrome will often have more information than the user has. And so we've thought about, there could be cases where we would say, this page is taking a long time to load. Like, do you want to continue? Do you want to wait? I think actually many web browsers will already do that with blocked main thread. So if there's like some infinite loop detected on the page and it's frozen, it might look to the user like it's frozen, but it's actually not frozen. It's just in an infinite loop. And then the browser will intervene and it'll show you a pop-up that says, like, this page is, kind of stuck or something. Do you want to kill the task, or do you want to wait? And so you have that option. I definitely think that I've seen that happen in Firefox. I can't remember if it happens in other browsers as well. So I think browsers do this. I don't know if a browser would ever say, historically, this site has been slow, and so now before you even start loading, we're going to warn you, oh, by the way, you sure you want to go to this site? It's kind of slow. I don't think we would do something like that. I think, with like the search ranking changes, we're already kind of providing good incentives for site owners to like, we think that's a better approach. We don't necessarily want to, if the user signals that they want to go to a site, we don't necessarily want to tell them that they shouldn't, because we think that they shouldn't go to this site. I don't think that we would ever do something like that. There are a lot of other things that like could happen. We could, there was actually, you might recall a while back, there was we posted on the Chromium blog that on mobile, people who long press on a link, it shows the kind of what's like known as the context menu, and that will display like link to open this in a new tab, or whatever. And then we had a badge that would have a check mark, and it would say fast site, and that was based on Core Web Vitals scores. So if the website had gotten within the 75th percentile on all the thresholds, it would just let you know that this site was fast. And so often on mobile, depending on what connection you have, you might not want to invest in loading a page, but seeing that badge that the site is fast, might give you the confidence that, yes, I can click on this link. So we had that out there for a while, and we ended up, I believe, taking it out, just based on some feedback we got from users and from site owners. So it's a tricky thing to do, but it's certainly something that's been discussed. It's certainly something that I think, like ultimately, browsers are trying to optimize for their users. Like, of course, they're optimizing for developers to some degree, but ultimately, if a user is having a better experience with one browser than another, they're going to stick with that browser. And so, like, browsers are they're products. They're trying to make users happy. They're trying to make users feel like they made the right choice with this browser. And so they're looking at ways where they can improve that user experience, and helping users determine which pages are kind of good for them, I think, is something that browsers are thinking about how they can do more of.
Yep.
But it's tricky with all these things.
And I think to wrap up, kind of continuing from this, I want to do one more thought experiment with you, because I'm so lucky to have you as a guest on this podcast, and I really want to know what you think about this. But let's say I can give you now godlike powers in navigating the world of web browsers, and you don't have to worry about things like cross-browser compatibility or polyfills or anything like that. If you could change any aspect of the web browser and browser technologies at the snap of your fingers, with regard in particular to what we've been talking about today about performance and better page experience, what would you do, and why would you do that? Why would you change that?
You gave me a heads up that you were going to ask me this question, and I still don't necessarily have. It's not that I don't have a good answer; it's that I have too many answers. For the sake of this discussion, though, and I kind of already hinted at this, but I think one of the biggest challenges that we have right now in measuring performance is that we have this blind spot of single page applications, where like the technology to build single page applications was never intended for that use case when it first came about. Like technologies like Ajax, and I mean, I suppose the HTML5 history API was built around this purpose, but it's also quite old. And so the problem, as I was kind of hinting at before, is that there's no standardized way that people build single page applications. There's so much variance. And there's so many cases where something could fit all of the, kind of criteria of being a typical single page application route transition, but not be, because the page, just happens to use all of those same APIs for a different purpose entirely. And so from the perspective of performance measurement, there's no good way that we have right now to say, this site is a single page application and it's super fast because all of its route transitions are super fast. We just don't, like, we can make some guesses, but if we're talking about metrics that will apply broadly across the board to all types of sites, we don't have kind of good tools or heuristics at this point to answer some of those questions. So it's something that we're working on. And one of the APIs that is promising is there's a new, I don't know if you've seen this proposal, there's a new proposal in the WICG called the App History API, which is kind of just a rethink of the original history API. And this solves a number of problems with like the history API, and so many people, like there's so many libraries out there that all they do is they just kind of work around all the complexity and the bugs in the history API. But for the purposes of performance measurement, one of the things that I think is promising and interesting about this API, and we kind of specifically designed it with this use case in mind, is that it requires a user intent and on some level, or I shouldn't say it requires it, but it will differentiate between, when a user does something that would then signal that the browser should load a new page, versus when the developer could just run some code that would just randomly update the URL whenever they wanted to. So, like for example, right now you can just call like history.pushState whenever you want, and you can update the URL with something. But if you can imagine an API where you could only do this in response to like a navigate event, where there's like the user clicks on a link and the developer gets this event, and they can decide to do nothing, in which case the browser will just load the new page like normal, or they can intercept this event and they can say they're going to like respond with a different action. And then they can choose to then kind of cancel that event and then like update the page however they want. In this case, they're limited to when they can make that update to when a user signals their intention to navigate away from the page. And then that would give us the ability to at least know that the user is trying to navigate. And so we can give you some kind of performance, kind of information about this interaction that the user has initiated on their own. as opposed to today where we could say, okay, well, there was a history.push date call and, 100 milliseconds before that, there was a link click. And we think that these things are related, but we're not 100% sure. And so we could maybe give you some timing information, but it could be wrong. It's super complicated. But with this app history proposal, at least that bit would be a bit more clear. And then like the proposal, like the event.respond with method would take a promise that could be a fetch or some other API that makes a network request. And then once that promise resolves, then we could say something like from the event timestamp till when the promise resolves, and then the next paint after that promise, that is the kind of like first paint of this particular route transition. And we could expose that time information to developers. So then they could optimize their like SPA route transitions based on that metric. And it would be much more accurate and much more reliable than like what we can do today. So that's something that I think is kind of promising. Right now it's still an experimental form. I think it's behind a flag in Chrome. It's, totally subject to change. There's a lot of things to still work out. And it's one of those things that we know that even if it does ship in Chrome, it will probably be a long time before it's widely available to all browsers. One of the things that we designed it's mostly polyfillable, which means, to people that don't know that term, it just means that you can kind of recreate the functionality in JavaScript. And so even if, say, Firefox or Safari doesn't support it when Chrome releases it, you could include a JavaScript library that would kind of do this similar things. And so you wouldn't get that same browser signal in Safari, but at the same time, Safari and Firefox aren't, at least yet, reporting the core vitals metrics anyway. So from that perspective, you wouldn't necessarily be worse or better off. You would still get like you could get the signal in Chrome. You wouldn't necessarily know in Safari, but in most cases, things that make the page faster in Chrome also make the page faster in Firefox, right, and also make the page faster in Safari. And so it would still be good to have some data on the speed of that navigation rather than no data at all. So that's, I think, an API that I'm excited about.
Well, when the app history API progresses further down the standards track, I think we'll have another chat with you about SPAs that time. We almost went there this time as well, but we're an old-fashioned podcast where we optimize for duration and not for listener experience. So we're going to have to wrap this wonderful interview up. Thank you, Phil. It's been very, very interesting. I think that we're obviously going to add all these resources to the show notes so that people can follow up on this stuff. Could you please tell folks where to find you and where to read your work about these things and other things as well?
Yeah, so for all of the Web Vitals stuff, web.dev/vitals is probably your best kind of one-stop shop for all the information there. If you follow the web.dev blog, you'll get lots of other content as well, but you'll get kind of everything that we publish about Web Vitals. For me personally, I not as much recently as I used to, but I occasionally write on my website, which is philipwalton.com. Also, you can follow me on Twitter, where I occasionally post links to the things I write about on my website. At Phil Walton, my Twitter handle, which is different from my domain name, just because I like confusing people. And, on GitHub, Philip Walton, and others, coding sites, Philip Walton as well. Twitter is the only one where it's Phil Walton. So if you go to the Philip Walton, he's a very nice gentleman who will politely redirect you to my Twitter handle. So you can't go wrong no matter what you do with Philip Walton.
Great, thanks. We'll add those to the show notes as well. Thank you so much, Phil. Thanks for spending time with us on this podcast.
Yeah, thanks, Simon. Thanks for having me.
Well, there we go. The first episode of the Technical Marketing Handbook in the books. A huge thanks to Philip Walton for being such a great guest and a great sport. Thank you for listening, and if you enjoy the show, don't forget to tell your friends and to subscribe if you haven't done so already. Remember to check out the show notes as well, and we'll be back in a couple of weeks with the next episode.